Good morning. Today I'm going to talk about using graphs to determine motion, to interpret motion just by looking at graphs. This is very important because this will be a question on the final. And there's essentially two different kinds of graphs that they'll give you, and they have very different interpretations. A flat line on one is very different from a flat line on the other. So you need to be able to recognize what kind of graphs they are and what different kinds of lines would mean for each one. Once you know that, they're actually fairly simple. We call these motion graphs. Now, first, a little bit of review. We said that speed or velocity is distance divided by time. The only difference between speed and velocity is that speed is simply distance divided by time, and velocity is that, but it also gives you direction. But the formula remains the same. Now, suppose we were to graph this, to have a graph where the y-axis is distance and the x-axis is time. And if we were to plot out how fast something is going at a steady speed, in 1 second it goes 10 meters, in 2 seconds it goes 20 meters, in 3, 30, 4, 40, you would end up with this red line here. And the slope of that line, any point you take on that line or any 2 points and subtract them, divided by the amount of time it took, would give you, let's make it simple. In 4 seconds, it has gone from 0 meters to 40 meters. So a distance is 40. The time was 4. 40 divided by 4 is 10 meters per second. If we were to take two separate points, like this point here where it's in 3 seconds, it's gone 30 meters, and in 1 second, it's gone 10 meters. If we were to just look at that interval, we would have distance is 30 minus 10, so 20. The time is 3 minus 1, so 2. 20 divided by 2, 10 meters per second. Same result no matter what. Now, the blue line is a much flatter line. We can see that in 4 seconds, this person has only gone 10 meters, whereas in 4 seconds, the red line had gone 40 meters. Clearly, this person is going slower. And that is something you should be able to interpret from a graph, that a flat line, a less steep line, has a smaller slope. Doing our distance over time, we could have, he's gone 10 meters in 4 seconds, so 2.5 meters per second is the speed. So again, just know that in a distance versus time graph, the steeper the slope, the faster the object. If they gave you 4 different lines here, 4 different colors, the steepest line would be the fastest, the flattest line would be the slowest. And this graph here puts together all the possibilities that you could have on a distance versus time graph. And again, I have to emphasize, when you're given a graph, the first question you need to ask yourself is, what am I looking at? Is this a distance versus time graph or a velocity versus time graph? Those are the two you're most likely to get. In a distance versus time, it's showing you how far you've gone in a certain amount of time. And if we see this first one, this first bit of the line here, it's a sloped line. It starts out flat, and then it begins to slope upward. This is acceleration. In a distance versus time graph, a curved line is telling me that it's acceleration. And because it starts out flat and then gets steeper as we go on, this one is showing positive acceleration, starting out slow and speeding up. If you look at the very end on the other side of the graph, we have where it starts out steep and then steep. If you look at the other side of the graph, you see it starts out steep and then it gets flatter and flatter as you go on. That would be slowing down. Both of them are acceleration, of course. Acceleration is changing velocity. Now, what's not changing velocity is a straight line, because a straight line would have the same slope, the same speed everywhere. So this very first sloped line here, relatively flat, but it's a constant speed. Since we're not given any numbers here, we can't calculate what the speed is. And then you'll see it changes. It becomes quite steeper. That would be speeding up. But look at this flat line here. Flat lines are very important because those are the big differences between the two kinds of graphs. If it's a flat line, that means that whatever this distance is right here, it has not changed. The seconds are ticking by, but I'm not going any greater distance while I'm standing still. That's what it means. If time goes by and you're not moving, you're standing still. And then It's sloping again, but now it's sloping downward. Now that can be confusing. What does that mean? Is that negative speed? Well, in a sense, it is, because what they're saying is you're heading back to where you're beginning. It's sloping down because now the distance from the starting point is decreasing. We're going back toward it. But again, just get the slope of that line. And this looks like the steepest of the different lines. So this would be the fastest speed back toward the end. And then at the very end, it suddenly slows down to a stop, as you might expect. And we see a curved line once again. So keep in mind all the different possibilities here. Curved line means acceleration. A straight line means a constant speed. And a flat line, a horizontal flat line, means a constant speed of 0. But there's a second kind of graph, a velocity versus time graph. In this case, we're showing the velocity is increasing. We're going, as each second goes by, from 0 seconds to 4 seconds, we're going up, 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 up. It looks like we're going up 2 meters per second every second that goes by. So in the first second, we're going 2 meters per second. At 2 seconds, we're suddenly going 4 meters per second. At 3 meters, we're going 6 meters per second. We're speeding up. This straight line is not showing a constant speed, it's showing acceleration, a constant acceleration of 2 meters per second per second. Every second, we're going 2 meters per second faster than we were before. Look at the flat line. The flat line is what confuses people, because they're thinking, oh yeah, flat line, that means 0. That means we're not moving. That would be true if this were a distance versus time graph, but this is a velocity versus time graph. We're moving. We're moving at, in this case, 8 meters per second. We're not standing still here. This is 8 meters per second. You're going at a nice steady space. You've put on cruise control, and you're just moving ahead at that pace. And then negative acceleration. So now we're slowing down. Now, if this were a distance versus time graph, there would be a curve. This is velocity versus time. Acceleration is a straight line. And it shows, this looks like a steeper curve. So let's see, in 7, 8, 9, 10, in 3 seconds, we've gone from 8 all the way down to 0. So the change in velocity, we were going, remember, acceleration is change in velocity. It's the final velocity minus the initial divided by the amount of time. Now, the amount of time is from 7 seconds to 10 seconds. And the final velocity was 0. So, and the initial velocity was 8. So 0 minus 8, negative 8, divided by 3 is 2.66 meters per second per second. So yes, that is a faster acceleration than the initial acceleration, which was just 2 meters per second per second. So this right here kind of puts them next to each other. You can see the difference. A stopped object would be a flat line on a distance versus time graph, because distance is not changing. And it would also be a flat line on a velocity versus time graph, but it would be a flat line at the very bottom, because it would show that there is no velocity. It would have to be flat here. It could not be flat up here. Look at the next one, constant velocity. In a distance versus time graph, a constant velocity is a rising straight line. And the slope of that line would give you the velocity. In a velocity versus time graph, a constant velocity that is not 0 would still be a straight line, a straight flat line at whatever that velocity is. It's not down here at the bottom. That's when we said it was stopped. It had a velocity of 0. Here it could be a velocity of 10 meters per second or something, but it's going to be a flat line. So make sure these two flat lines, you understand the difference between them, between a flat line on a distance graph versus a velocity graph. And then the last one is just constant acceleration. In a distance versus time graph, it is a curved line that starts out, if we're speeding up, starts out flat and then gets steeper. And in a velocity versus time graph, it is a straight line that is off at an angle, and the slope of that angle would be the acceleration. So I've got a few different things going over this. We'll talk about this in class, and there's some reading and other videos for you to watch. Motion graphs cause people just all kinds of trouble, but the most important thing when you're given a graph, just stop, calm down, and just ask yourself, what is this showing me? And if you understand what it is to have distance versus time, it's pretty obvious that if your distance is flat, if you're not changing your distance at all, you're standing still. And if, on the other hand, you're looking at velocity versus time, well, what does a flat line mean in velocity versus time? It means it was a velocity of 8, 8, 8, 8. The seconds are going by and I'm going 8 meters per second. I'm not stopped. I'm just not accelerating. So one means stop dead, no change in position. The other one means changing position, but I'm not increasing my speed. So just look at the kind of graph you have and understand what those flat lines mean, and then the rest of it becomes pretty simple. Thank you.